It wasn't actually that long ago that scientists thought that your brain was pretty much fully cooked by the time that you're a toddler. By that, I mean they thought that your brain was pretty much set and it wasn't going to experience very many changes as you grew up. But that's not true at all. There's this concept called neuroplasticity, and that says that your brain is capable of change throughout your entire life. And to me, that's one of the most hopeful things that we have going for us until they find a cure. So every single brain is unique, and it's a combination of all of our life experiences, and it continues to change and form new connections. It is the highest when you're a baby, that's true, but it also increases as you're learning, especially if you're really paying attention. And it's really high if you have an injury to your brain or even your spinal cord. So after every single flare-up, our brain is working really hard to find workarounds. It's sort of like searching for a detour. Sometimes it might take longer to get from point A to point B because the road is blocked, because there's a lesion there, but the science shows us that often you can still get to your destination. When you have a flare-up, recovery is likely because of plasticity. People with MS actually have really different patterns of brain activity than people who don't have MS, and you can adapt to all these new patterns. Think of it like how people's brains can learn to see with two different contact lenses. They have like a nearsighted one and a farsighted one. That would probably seem really crazy to your brain when you first put them in, but it actually only takes your brain a couple of days to figure out how to make that make sense. Similarly, if your brain found a workaround for a lesion, it's going to become normal for your brain to do it that way. Within the brain, there are 100 billion neurons, so that's a lot of room for workarounds, but it's not a guarantee that your brain can always find a way. There is more room in some places of your brain than in other places of your brain. You can see the section on lesion, location, and impact to learn more about that. The good news is that you can have brain changes in the gray matter by growing new nerves and building new synapses, and in the white matter by changing the size of axons and changing the branches and the trajectories of the axons. And neuroplasticity can happen no matter your age, what type of MS you have, when you were diagnosed, and the stage of your MS. Doing things that promote neuroplasticity, like learning new things or doing brain games or doing exercise, can all help restore function. Now, the bad news is that neuroplasticity works in both ways. For instance, if you learn to move badly, that can change your brain to make those bad movement patterns stick and be harder to unlearn, which can mean worse or sustained disability. Recovery-oriented interventions like neurophysical therapy can often help your brain find the way. There's even some research that says it might even result in some remyelination. There are 4 different types of neuroplasticity, and you're going to see most of them happen in MS. The first one is called map expansion. In the motor cortex of the brain, if you do something a lot, you're going to get more brain space for what you're doing. If I all of a sudden decided I was going to take up the guitar, the nerves that control fine motor movements of my hands would start to expand as I started learning how to play chords. For instance, I don't know if you play guitar, but I see my husband play and how he holds his fingers. Like, my fingers don't move like that because I don't play guitar. But if I started playing guitar and practiced, I would be able to move my fingers that way. And then the part of my brain that controls my fingers would expand so that is easier. On the flip side, if you're not using a part of your body, your brain doesn't need to have that space to control that part of the body. So while you're having atrophy in a muscle that's not being used, you're also having atrophy in the part of your brain that controls the muscle that you're not using. Now, kind of as part of map expansion, there's something really interesting called Hebb's postulate. And Hebb's postulate says that nerves that fire together wire together. So if you held your hands up and you were folding your fingers, there's a good chance that when you folded your pinky finger, your ring finger would want to go along for the ride. The reason for that is that it's very rare, unless you're doing things like playing piano or guitar, that you need to use your ring finger and pinky finger really independently. Like, you use them when you're gripping things, you use them when you're picking stuff up, but there's not a lot of times that you're just, using your pinky finger by itself. So what happens is these 2 body parts are right next to each other in the brain. So the nerves end up kind of smudging. They get confused as to which one does what, so they just both end up firing together. Another common type of neuroplasticity that you see in MS is compensations. Now, the official name for that in the neuroplasticity world is compensatory masquerade, which is a really cool name for a band, but a very complicated name for a compensation. So every time you have trouble doing something, you're going to come up with a compensation. And a lot of times you're not really thinking about what it is. If it's hard to walk, you're going to start walking in a different way, and you're not really sitting there thinking like, it's hard to lift my knee up. What could I do instead of lifting my knee up? Your brain is just going to automatically throw something in the mix, and it might be a good choice, and it might be a choice that ends up causing you hip pain or back pain or whatever. So the job really of neuro PT or an exercise specialist in MS is to watch you move and to say like, that compensation, that might not be doing you any favors. So we see this a lot in foot drop, where we see people do the different gait patterns that we talk about in the walking section of the workshop. Now, those of us with MS and those of us who don't have MS are always coming up with compensations all the time if there's stuff that we're not particularly good at. One of the things that I'm not really particularly or at all good at is directions. There's a brain game on Lumosity, which is sort of this collection of brain games, and it tests your ability to do spatial relations. So you have sort of, it's almost like a Pac-Man board, and you have a little penguin who's going through this maze and it's trying to find food, and you control it with the arrow keys. So you have like an up key, a down key, a left key, a right key, and then you would move, the penguin through the maze, and it starts off and it seems like it's really simple. Well, all of a sudden, the maze itself starts to spin. So what was up is now left or right or down or something, and then sometimes it'll spin more than once. So I was doing this, and my poor penguin was like braining himself on the wall of the maze because I couldn't really figure out, like my brain didn't get how to get him through the maze. So the compensation that I came up with, on the fly without really thinking about it, was moving my computer as the penguin was moving so that I could just keep moving it around. So my up was always up in the direction that I was looking at it. So my husband, who does not have the same spatial relations disability that I do, went into the exact same game and got like a score of 20,000. And I think my score was like 250. So different people are going to have different strengths and different weaknesses. And if you have weaknesses, you come up with compensations. You also have another type of neuroplasticity called mirror region takeover. And in mirror region takeover, what happens is what's usually done on the left side of your brain goes to the right side of your brain and vice versa. Now, the left hemisphere of your brain controls the right side of your body, and the right hemisphere controls the left side of your body. And they're connected by something called the corpus callosum, which is sort of like a super highway of information to go from the left to the right. Now, if you ever see a kid who's drawing on a piece of paper, and when they get to like sort of the middle of their face, they pick the crayon up and start going with the other hand, that means that the two hemispheres of their brain are not communicating with each other. And you want the two hemispheres of your brain to communicate, and you definitely want them to communicate if you're hoping that some sort of neuroplasticity magic is going to happen. So the way that you get more mirror region takeover happening is you do stuff that crosses the midline. So you move your right arm across your body to the left. So that would be something we would do like in the exercise world. We would also do cross-patterned exercises, which means that your right limb does something different from your left limb. So there's an exercise called bird dog. It's a really common one. It's where you're on hands and knees and you reach your right arm forward and your left leg back. That is a midline crossing exercise in terms of how your brain kind of sees it. One that I actually teach in my workshops, which is really popular in terms of how much people don't like it, is doing itsy bitsy spider. So if you do itsy bitsy spider, you have your index finger and thumb together, and then you move your index finger and thumb. And so that is getting your left hemisphere and right hemisphere of your brain to talk. Now, I advance it by thinking you're always on your thumb. Then you go to your middle finger, ring finger, pinky finger, and then you start to go back down. And you do get better at it if you practice it, but that is a good way to get the two hemispheres of your brain talking. So hopefully if something is messed up on one side, the other side might be able to help you out. And the last type of neuroplasticity is something called sensory reassignment. Now, I don't really know if this happens for people with MS. It happens a lot with people who are blind. If you go to your behavioral optometry section and you listen to the discussion about the difference between eyesight and vision, eyesight is just one small part of what your brain does with that information that it gets. So at the back of your head is where your visual cortex is, and that kind of handles all that different information that's coming in from your eyes. Well, if you don't have eyes, it seems like a tremendous waste of space to have this entire, visual cortex back there. So what ends up happening in people who are blind is when they're reading Braille, it actually fires the visual cortex. It does also fire, the fingertips, like the part of the brain that you would think it would fire, but it's almost like that you're supposed to use your sight to read. That's an example of sensory reassignment.